This is the video for solving compound inequalities, 6-4. There is a PDF available if you'd like to print it out and follow along. Compound inequality, first of all, is an inequality that consists of two separate inequalities, but they're joined by the words and the word or, kind of like a union or an intersection on sets. If we do a compound inequality with the word and means intersection, the overlap. So if I have x is greater than -2 and x is less than or equal to 1, I can graph them separately, like this. And only where they overlap each other, like this, only the overlap or the intersection of the two is the solution. So graphing this and that is actually between the dots, not including this one because that's not part of the solution of that one. The word and, as we've already said, means intersection. Anytime you have the word and connecting compound inequalities, you can actually write it as a single inequality like this, a single compound inequality where the x is between. So the word and kind of means between. It also means intersection, but it kind of means between as well. Compound inequalities with the word or really means union, where we combine the answers of both. So in order to be a solution, it has to be a solution of this one or that one, but it does not have to be both. So it's not an overlap, it's a combination of both. So here we go, we got x is greater than or equal to 0, going that way, and x's are less than -1 this way. So all x's that are less than -1 or x's that are greater than or equal to 0, this one or this one. So the solution is the entire graph, not where they overlap. There is no intersection on this, so if you tried to treat this like an and, there'd be no solution because there'd be no overlap. But since they use the word or, we want all these answers and all those answers. That's the union. Combining them all together, adding them together, creating a new set. Example 1, translate the verbal phrase into an inequality, then graph the inequality. All real numbers are less than -1. Let's use n for our variable. All real numbers n less than -1 or greater than or equal to, so n is greater than or equal to 4. You see that this is a italicized or. So that's the distinction between this side and this side. That's our two inequalities. Now using an or as a union, so I can't look for the overlap, not an intersection. So if I go and graph these, let me graph this one first. There's 0, -1. Open circle because it's not equal to, and it's facing away from the variable, so I'm looking for numbers that are smaller, so that means to the left. Graph this one now. 0 is there, 4 is on this side. Closed circle. Looking for numbers bigger than 4, it's opening towards the variable, so that's arrow to the right. So the solution, because we're using the word or, would be adding both of these together. And this ends up being the solution of that compound inequality. Translate into an inequality, then graph. This one's using the word and. So all real numbers, let's use n again. N greater than or equal to -3 and less than -5 means n is less than, not -5, +5. Now since it's using the word and, I could write this as a single compound inequality. Put the bigger number on the right-hand side, put the smaller number on the left, and n in between. N is less than 5 and greater than or equal to -3. So I can rewrite this because of the word and like that. So I want to go and graph them. So this one's going to have an arrow at 5 that goes left. This one's going to have an arrow, so a solid dot at -3 going right. And I only want the intersection, the overlap, the intersection, the and. So we'll call that 0, we'll call this -3, we'll call that +5. So at positive 5, I have an open circle. At negative 3, I have a closed circle. And is meaning between, so it's between them. So I only want the part that's between. Because this graph over here technically would go, let me get rid of part of this, would go this way. And this one over here would go that way. But I only want the spot in which these two graphs overlap, and that's in between. Okay. Example 3: crane sits on top of a camera car, faces towards the front. Crane's maximum height and minimum height are shown here. This might be a little difficult to read. Write and graph a compound inequality that describes the possible heights of the crane. So the possible heights of the crane. I don't know what the heights are, so I'm going to use h. And the maximum height I'm going to put on the right-hand side, which is 18. And the minimum height is going to go on the left side, which is 4. And h is greater than or equal to 4, and at the same time less than or equal to 18. So this is my compound inequality. My crane can be anywhere between 4 and 18. And I do have to put an equal to because it does say it can go to 4, and it does say it can go to 18. Go and graph them. This is 0, we'll call that 4, we'll call this one up here 18. I have a closed dot at both points, and since I'm looking for h's that's between them, that's a compound inequality with an and. I want just the parts in between them, which is this graph right here. Example 4, an investor buys shares of stock will sell them if the change, C, so they're telling us what variable to use. The change in value from the purchase price of the share is less than negative 3, or, that's a key word there, greater than 450. Write and graph a compound inequality. So use the word or, so that means we're going to have a union. Let's see, C should be less than negative 3, so less than negative 3, or they will sell them if C is greater than 450. And I don't need the 0, but I'm going to put it anyway. And then graph it. We'll call this 4, we'll call this one 5. So let me graph this one. This is C's are less than negative 3, so starts there, and less than, smaller, is this way. This one is open circle at 450, it's halfway between, and I'm looking for greater than. And since there is no overlap, and they didn't ask that anyway, it's not an and. If it was an and, there'd be no solution, because there is no overlap. So anything over here or anything over there is acceptable, and that's when the person or the investor will actually sell. Solve compound inequalities. This is using and, because it's written in between. We're going to solve it just like any other multi-step equation. We're going to subtract the 4 from both sides. That makes a 0 in the middle, leaving 2y less than or equal to or greater than or equal to. 10 minus 4 is 6. 24 minus 4 is 20. And now to isolate the 2, we're going to divide by 2, but I have to divide by 2 on both sides, so that gives me a 1 in the middle, 1y, less than or equal to, greater than or equal to. 6 divided by 2 is 3, 20 divided by 2 is 10. And that's how you solve using an and. We could, of course, graph this if we want. Closed circle at 10, closed circle at 3, and since y is between, a line connecting them. Now we're going to solve using or. Since or cannot be written as one statement in between, you have to solve these separately. So we're going to minus 1, minus 1. 3h is less than negative 6. Divide by 3 on both sides. And we end up with h is less than negative 2. That's this side. Now I'm going to go ahead and solve on the right-hand side. I'm going to add 5. So I bring down my 2h greater than 7 plus 5 is 12. Divide both sides by 2. H is greater than 6. And don't forget to bring down your or. Or has got to come all the way down. So if I were to graph this, because it has the word or, it wouldn't be between. 0, we'll call that negative 2. Let's change that. Negative 2. This side would be positive 6. This side over here has a open circle, and numbers that are less than negative 2 would be this way. Over here I have an open circle also, but I'm looking for numbers that are greater than 6. That would be this way. And because of the word or, both of these answers are okay. Anything over here or anything over there. And that's where the word or comes into play. That's a union, combining all these answers with all those answers. Example 7. Mars has a maximum temperature of 27 Celsius at the equator and a minimum temperature of negative 133 Celsius at the winter pole. We got two parts here. Write and solve a compound inequality that describes possible temperatures in Fahrenheit. This is kind of a key here. They gave us information in Celsius, but they're asking us to write it in Fahrenheit, so they're kind of telling us what our formula is going to be. Graph your solution. Identify 3 possible temperatures on Mars, but identify them in Fahrenheit. Okay, so the first thing we're going to do is set up our high number, our high number of 27, our low number of negative 133, and in between, because this is a range from here all the way down to there, so I know it's got to be in between. I have to come up with the formula, but what I'm going to be doing is taking these Celsius numbers and converting them into Fahrenheit. So what you have to do is look up the formula for converting Fahrenheit into Celsius. All right, so what I'm going to do then is write down what that is. If you don't know what that is, go ahead and look it up. The formula is, I'm going to write this in a different color, 5/9 Fahrenheit minus 32. 5/9 times Fahrenheit minus 32. And then I'm just going to solve for F, isolate F. Okay, so the first thing I'm going to do is get rid of my 5/9. Since I have a times 5/9 here, I'm not actually going to distribute it. I'm going to multiply both sides by reciprocal. So I'm going to come over here and times by 9/5, times this by 9/5. And since I have a denominator here of 5, I'm going to go ahead and divide that out, because dividing by 5 gives you a nice decimal, and this is not evenly divisible by 5 anyway. So 9/5 is going to end up giving us 1.8. So I'm going to multiply by 1.8 here. So negative 133 times 1.8 gives us negative 239.4 degrees, less than or equal to Fahrenheit minus 32. Because remember, when I multiply by the reciprocal on both sides, it eliminates this. But I still have a minus 32 in the middle, and I got to multiply this by 1.8, so 27 times 1.8 gives us 48.6 degrees. And now to get Fahrenheit by itself, I still have to add 32. And this becomes 0, so I have Fahrenheit less than or equal to, greater than or equal to, and a negative 239.4. I'm going to add to it 32 degrees. That brings it down to negative 207.4 degrees. Or, on the other side, 48.6 plus 32 would give us 80.6 degrees. So this was the original equation up here in the blue with the red. And then I solved it through to get Fahrenheit by itself. So what that did was take these Celsius calculations, or Celsius numbers, and convert them into their Fahrenheit equivalents. So that would be the first part here. The second part says graph. I'm not going to go ahead and graph that because this number is way too small. But you'd have a negative 207 with a solid dot over it, positive 80.6 on the far right with a solid dot. And since F is in between, you'd have a line connecting the two dots. They do want us to identify 3 possible temperatures. So any temperature that fits here within this range would be acceptable. So you could choose 0 degrees Fahrenheit, or you could choose negative 100 degrees Fahrenheit. That would fit here possibly. And let's go on the high side. Let's do 55 degrees Fahrenheit. So there's 3 possible temperatures on Mars, depending on how close you are to the pole or the equator.